Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Your Royal Highness, the Crown Prince of Perak Darul Rizwan, Raja Nazrin Shah, the Honorary Chairman of Bridges Malaysia, Your Royal Highness Tuanku Zahra Salim Davidson, Yang Amat Berbahagia Tun Dr. Siti Asmah bin Haji Muhammad Ali, Yang Amat Berbahagia Tun Dr. Ling Yosek, Yang Berbahagia Datuk Syahrir Samsudin, Honorary Treasurer Perdana Leadership Foundation, Yang Berbahagia Tan Sri Samsudin Osman, Presiden Perbadanan Putrajaya, Mr. Yui Morawat, Chairman of the International Peace Foundation, dan Yang Berbahagia Tan Sri Nik Muhammad Nik Yaakob, Executive Director Perdana Leadership Foundation. It is my pleasant duty this afternoon to introduce the Bridges keynote speaker, Professor George Fitzgerald Smoot, Nobel Laureate 2006 in Physics. And Professor Smoot will be talking on the topic of contemplating the birth of the universe. I must admit to having a lot of black holes, translate that into deficiencies in my knowledge of astrophysics and cosmology. So therefore I look forward to the lecture. Maybe those black holes can somewhat, or a few of them can disappear. Our universe is said to be between 10 to 15 billion years. Now, if you can compute that, it's quite difficult to compute that kind of time frame. Or in the language of cosmology, it is in the 10th cosmological decade. The possibility that the universe began as an explosive burst first seriously suggested in 1920s, and the idea became dubbed as the Big Bang. About the same time, it came to be realized that if the dawn of the universe was indeed explosive, then a faint afterglow of this explosion might still remain and be detectable. In 1964, two scientists realized that the microwave background radiation flooding into their radio receivers was indeed such a signature of the Big Bang. Owing to the interference caused by the Earth's atmosphere, however, it was impossible to see this radiation unimpeded. In 1889, 15 years after it was first proposed, NASA's COBE satellite, COBE meaning Cosmic Background Explorer satellite, was launched to study cosmic microwave background radiation from orbit. Within minutes of starting its recordings, it confirmed that this diffuse radiation displayed precisely the expected frequency, wavelength relationship, the perfect black body spectrum predicted to result from first light in the universe. Here is where the work of our speaker today is of major significance to the Big Bang theory. Professor George Fitzgerald Smoot is director of the Berkeley Center for Cosmological Physics, who was awarded the 2006 Nobel Prize in Physics, along with Dr. John Mather, for the discovery of the black body form and minute variation of the cosmic microwave background radiation. In April 1992, Professor Smoot announced that the team he led had detected the long-sought variation in the early universe that had been observed by NASA's by NASA's COBE. And NASA's COBE satellite mapped the intensity of the cosmic background radiation from the early Big Bang and found variations so small, about 1 per 100,000, they had to be seeds on which gravity worked to grow the galaxies, or as well as clusters of galaxies and clusters of clusters that are observed in the universe today. These variations are also relics of creation. Essentially, Professor Smoot recorded the faint echoes of the birth of the universe. The precise satellite measurements of the cosmic background radiation confirm fundamental prediction arising from the Big Bang theory, leading to its further acceptance as the standard model of cosmology. The discovery, called the discovery of the century, if not of all time, by the famous astrophysicist Stephen Hawking, was the first step towards understanding the development of structures in the universe. Professor Smoot was born on February 20th, 1945 in Florida. His father, an engineer, was a hydrologist for the U.S. Geological Survey, and his mother was a science teacher and school principal. He studied at the Massachusetts Institute of Technology, where he earned Bachelor of Science degrees in Mathematics and Physics in 1966 and received his PhD in Physics in 1970. Although his doctoral thesis was on the decay of subatomic particles, Professor Smoot jumped to the field of cosmology for his research because he saw it was a frontier of fundamental science ripe for exploration. He is the author of more than 200 science papers and of the book called Wrinkles in Time that elucidate cosmology and the COBE discovery. A professor of physics at the University of California at Berkeley, his honors include the NASA Medal for Exceptional Science Achievement, the Lawrence Award, and the Einstein Medal. Professor Smoot continues research in cosmology and is involved in the Planck and SNAP mission. The European Space Agency Planck mission is the third-generation mission to exploit the cosmic background microwave fluctuations discovered by COBE. SNAP is a mission to understand the dark energy causing the current expansion of the universe to accelerate.